Welcome everyone, thanks for joining us. If you're online, thanks for joining us there as well. We're really happy to have Hanna Halaburda here joining us today. Professor Halaburda is on the faculty at NYU Stern School of Business. She's a professor of technology, operations, and statistics. And she's a leader in this emerging field at the intersection of blockchain, cryptography, and economics. So she's going to present today some research that draws on a few of her papers on blockchain tokens and how they're changing platforms, platform economics. And this draws also on a wealth of research she's completed in leading journals, in addition to having one of the very first textbooks discussing digital currencies from an economic perspective called Beyond Bitcoin, which, having taught some of in my class, some of my blockchain classes, I would highly recommend. So if you want to get the economic perspective on digital currencies, I encourage you to start there. With that, I'll turn the floor over to Hanna. You have about 45, 50 minutes.
Okay, thank you very much. And thank you very much for inviting me to present my research. Ariel said it's based on two papers that I had together with Yannis Miklos, my colleague at NYU. So as a brief background, my research, out of grad school and in early career was focusing on platforms, platform economics, platform economic forces. And starting 2011, I got interested in blockchain. And for a while, it was difficult to see, blockchain could be seen as a platform, but just with Bitcoin and early cryptocurrencies, it wasn't so easy. But now, as we have tokens and DAOs especially, it became clear how those two topics are merging together, coming together to provide us with new and exciting topics. So this is kind of the background behind these particular two papers that we had. And also, I'm going to be talking about platforms. I'm going to be talking about tokens that are based on smart contracts that are running on blockchain. However, I do not plan to give a primer on those technologies, because if we start with a primer, we'll never get to the actual research. I've tried it before, never worked. So instead, I'm going to highlight the important features of the technologies. But if you do have questions and you think it may be questions about technology, and you think it's important for understanding the topic, just ask questions as we are going along. So this will be a way of making this primer, substituting for a primer. There should be time built in for that, so don't worry. Okay, and I'm also happy to take questions as we go, rather than just wait for the end. If it needs to be, I will postpone. So blockchain technologies, now we kind of talk about blockchain technologies in plural. There are many things going on. There are the currencies, smart contracts, DeFi, DAOs, and so on. But it all started with Bitcoin. And right from the beginning, from Bitcoin in 2008, 2009, blockchain technologies were promising to decentralize, disintermediate, democratize, level the playing field for entrants, make the world a better place, cure cancer and everything. So we'll see about how far it can go, right? And then when all this is happening, when we decentralize and disintermediate, we can create more value and distribute it more evenly, and again decrease some of the inequality. So these were the promises that go back to the very first paper. So in a number of papers that I have with Yannis, and not only with Yannis, I'm looking into to what extent and under what conditions blockchain technologies and different blockchain technologies indeed can deliver on these promises and along these dimensions. So sometimes it may be important to distinguish between decentralization and disintermediation. So this is kind of a broader framework. And from this broader framework, like I said, we're coming down on to think about platforms, and especially how blockchain technologies will help us see the platform problems in a new way, and potentially may change economic forces in platforms. So kind of what is interesting for an economist, when an economist looks at technology, it's always interesting to ask to what extent technology can change economic forces, because it does, and it's internet really did change economic forces of platforms. And what are we going to see when blockchain comes along? Okay, so definitely what we're seeing is that blockchain technologies are enabling some new choices or new features of platforms. And when we are thinking about setting up a new platform, now we have more of those design choices available with blockchain technologies. And the question we are asking in those two papers is how those new platform design choices can help us solve old problems in platform economics. The old problems, the kind of main problems in platform economics, are coming from network effects. So network effects basically come from the fact that in platforms create value by bringing people together. So we are going to have more value from Facebook as more of our friends are actually using Facebook, and then there are more people to like our posts, more people to read posts from, and so on. In Uber is more valuable for us as passengers when there are more drivers, more valuable for drivers when there are more passengers. It creates this feedback loop that the more people join, the more valuable it is for new people to join. And this is the feature of the network effects. So that also means that anybody who is thinking about joining a platform will want to join a platform only if they expect or already see other people joining. Nobody really wants to be the only person on Facebook. It's not fun, right? And if you're the only passenger on Uber, also no use whatsoever. And if there is any cost of downloading and learning the app, then you are not going to get any out of it. In fact, maybe negative returns. Okay? So because of that, this feature that platform creates value only when there's already a lot of people on the platform, it makes it difficult, network effects make it difficult for platforms to enter the market. But once you are in and you are successful platform, the same network effects create defenses and barriers to entry for new entrants. And that makes it possible for you to increase the prices or requirements or some other ways in which users are paying for using the system. And those intermediaries that are taking advantage of the network effects when they are already embedded in the market, they can extract value from the system. It could be extracting data, like what Facebook does with our participation. Could be just plainly increasing prices because there are many more users and joining the network is valuable. Okay. So we ask specifically, there are, as I said, many different blockchain technologies. So we focus on tokens enabled by blockchains and smart contracts, and ask how tokens can help us to solve those two main problems for platforms that come from network effects. So kind of as a brief overview, what we are finding is that we look at two types of tokens. We look at utility tokens and governance tokens. Generally, there are three types of tokens. There's also equity tokens. We do not talk about those specifically, but almost any type of token eventually or partially becomes equity token as well. But utility tokens, and I will define it more about what I mean by utility token, but utility tokens that give access to the platform can make entry easier, which is nice. Right? Governance structures enabled by governance tokens, like DAOs, they allow for more value creation and more equitable value distribution. Okay, it's also nice, right? This is what we would like to see. This is why we are creating new technologies to get those benefits. Okay, but there's a but. Of course, there's a but. Each comes with its caveats. So what we are showing is that utility tokens make entry easier, but at the cost of lower overall profits for the platform. So yes, we can enter, but we're going to make less money overall if we use tokens to enter rather than subsidy. And when it comes to governance tokens, yes, there is the structure allows for more value creation, more equitable value distribution, but without additional safeguards, it's not going to actually deliver on it in equilibrium. And we're going to see this natural re-centralization forces coming to play, which will end, which will, without additional safeguards, like I'm saying, are going to put us back into a similar system that we're starting. Okay. So in the end, tokens may alleviate, but they do not fully remove traditional concerns. And there is more structure needed to make this new technology really work in the favor of increasing social welfare. So let me maybe briefly pause here. Are there any questions at this point? I am not monitoring for those who are on Zoom, I'm not monitoring the chat. I think Jamie is monitoring the chat, so that's it's more of the, I'm happy to answer the questions once I know about them. Okay. So let me start with the first one, with the utility tokens and the platform entry. And utility tokens here will allow for will be tokens that will allow for usage of a platform, either to just enter or to use for transactions. And the platforms that we had in mind when we were first constructing the model were platforms like Filecoin and Haeringer. I don't know how many of you are familiar with those platforms. Filecoin is a kind of a peer-to-peer substitute for Dropbox, where you can store your files, but you're not storing file on some company's cloud server. Instead, you're storing it on other people's computers, other people who have spare space in their computer, and they put it up for rental use. And this way, you can you can use somebody else's spare. So it's a little bit like gig economy for your computer hard drive space, right? And sharing economy. So of course, naturally, this is a type of platform that exhibits network effects, in the sense that only if there are a lot of users who are offering their space, and a lot of different users they're offering their space for storage, only then it will be valuable for the users who want to store their files. And only if there are a lot of users who want to store their files, it will be worthwhile for users who have this spare space to offer it up for rental. And in fact, those may be the same people, because you may want to store your files for security somewhere else in case your hard drive fails, but you also may be offering your space for somebody else's. So the reason why you don't want just one person who has a lot of storage, because there is a worry that if one person holds the whole file, even if it's encrypted, then maybe somehow they will decrypt it, they will see the file, who knows what they will do with the knowledge that is in the file, right? This is why some people worry about how Dropbox may abuse the fact that they are storing all those files despite the promises of encryption. But if you can see it in the setup of Filecoin, that each file is actually divided and spread among different users. So different users have parts of the file, and then it can, when you call it in, it magically comes, not magically, of course, it comes together and reintegrates before it's coming to you. But then it's safer. Even if they decrypt, they are not going to be able to do much with just part of the file. So you want a lot of people to be participating in the system, and only then it's valuable, right? This is a network effect that Dropbox itself doesn't really have, right? Because we just need Dropbox to use Dropbox. Helium is a peer-to-peer Wi-Fi service where people are setting up and allowing their own hotspots to hotspots to connect to each other so that you have more access to Wi-Fi and or across certain space. And it's specifically used, or it's envisioned to be used for Internet of Things connectivity, so that Internet of Things the things that are connected by Internet of Things can talk to each other via this peer-to-peer network rather than connecting to the main Internet. And this is in particular a very interesting example because naturally it has the same network effects, but for quite a long time, Helium could not really get off the ground and get enough people to join and turn on their hotspots so that they would connect, so they would have enough of coverage to make it worthwhile for users to use it, until they turned into tokens and started using tokens to incentivize people to actually join the network and connect their Wi-Fi hotspots. Okay, so this was an inspiration for the model that we have derived. So, like I said, this is talking about how this particular project is looking at how tokens can help platforms enter the market. And the reason why it's difficult to enter the market is because of the network effects. You only want to join if and only if other users want to join. And with that, we have two equilibria. Either everybody wants to go and adopt the platform and join the platform because they believe everybody else is going to join it, or nobody adopts because they believe nobody else is going to adopt. And this is, from the economic perspective, you can't really say which of those equilibrium will be played because they are both equilibria. They depend on beliefs. So how are you going to fix that? This problem has a long history in economics, going back to the 80s and then renewed with Tirol and Julian. The classic solution to this problem is subsidy. So basically, and this we have seen many times before, even before tokens, before internet, but especially with internet as well. You subsidize early users and profit from those who join later. And you later can make up enough money to recuperate the investment of subsidizing early users. So, for example, if you were an early user of PayPal, then if you were, early user, I don't know whether graduate students they are too young to be early user of PayPal. But if you were a very early user of PayPal, just for setting up an account, you would get $10 of credit. And it's PayPal, so $10 is $10 you can spend on anything, right? As long as you're paying PayPal. When you join Uber, you would get $10 credit on Uber, so it's a little bit less attractive than $10 that you can spend on anything from PayPal. But Uber and PayPal, they needed to get $10 to pay for thousands and thousands of people who are joining and setting up an account. But this is a very explicit subsidy. They're paying you $10. And obviously, later on, everybody wants to join PayPal. A lot of people want to join PayPal because it provides enough service. And then they recuperate this investment by charging the interest of the transactions. Now, the problem is that it requires upfront capital. The $10 times thousands and thousands of people, it's a lot of money that you need to have upfront before your future profits materialize. And that can be expensive, even if it's accessible, and sometimes may not be accessible at all if you don't have this upfront capital to start with. So this creates barriers to entry. So we were asking, whether tokens and using tokens to overcome this coordination problem and overcome this bad equilibrium that a lot of platforms are facing, whether tokens can help to overcome it. We found the need of this upfront capital, and therefore, by removing barriers to entry, it could level the playing field. Because the problems with barriers to entry is that some of very, very good ideas for platforms may never succeed in the market because of the network effect, not because they were bad ideas. Okay? So tokens, as they are run by smart contracts and on blockchain, they were popularized by ICO hype in 2017, 2018. They use, they build an earlier idea of platform-specific tokens. So platform-specific tokens are far older than crypto tokens and far older than blockchain, because Amazon has Amazon Coin. You may think Amazon Coin would be a big thing. Amazon Coin is a thing since 2013, but nobody probably heard about it. Facebook had Facebook credits that came and went, and then Libra came and went. But World of Warcraft has World of Warcraft Gold, which is a platform-specific token, so on. And some of them are tradable and others are not. So cryptographic tokens are very often, even those that started in ICO, but the ones that we specifically studied that for platforms, this would be platform-specific tokens that are easily tradable, because token, like if they are set up via smart contract on the blockchain, that they are easy to trade either via an external marketplace like an exchange, or we can just trade it between each other, and we can change the ownership on this external ledger without involvement of the platform itself. So we focus on utility tokens, and in our setting, the one token is going to be just platform access, but it also translates to a more complicated model when one token is a one use of a service. Okay. And utility tokens are enabled by smart contracts, like I said, just so that the ledger of the property of the ownership of the token is written on this external ledger and blockchain, but also the platform itself needs to have those components need to be designed to use the utility tokens. And specifically, what is important is that if you offer utility tokens and you say, I will accept utility token to access the platform in the future, you need to have a way to commit to accept those utility tokens. And this is very important for the future value of the utility tokens. And in the traditional world, it is really difficult for firms, for platforms to commit, not to basically make the tokens expired in the future, not to announce, your loyalty points are going to expire next month, right? Or we are graciously are going to extend them, right? When we are thinking about the airlines loyalty points and so on. So with smart contracts that are used for platform design, platforms can commit for future acceptance of those utility tokens. And this is also an important feature of the technology. So the two relevant properties of cryptographic utility tokens that we are focusing on are the frictionless or close to frictionless tradability of access, because we can trade tokens, and that has been kind of a thing for a while, but it is really easy to do it with crypto tokens. And the second is this commitment for allowing future access. And with that, we can look at this resale of access as a way to overcome coordination bias and allow or facilitate entry of new platforms. And this has not been explored before because probably it was difficult to commit to those without the technology to have those two features. So can cryptographic tokens issued on blockchain help to overcome the coordination bias for new platforms? There's no talk, right? Okay, so I'm skipping something, but okay. So tokens, what we find is tokens make it possible to reduce or eliminate early user subsidy. So if we need to subsidize users to join the platform because they are not really sure whether others will join, then with tokens, we're promising them some value, even if they want to exit the platform later on. Either they don't want to join, they didn't like the platform, they want to exit, they're going to have this token that they can sell later. And this is always something in your hand that may or may not have value, but in expectation it will have some value. That is better than if you just subsidize access, but then if user doesn't like the platform, exits and has nothing from it. Okay, so This way, they can charge higher price upfront or pay lower subsidy at the cost of the future revenue. So this way, they can tokens allow to move the revenue from the future to the present. Okay, and that helps to eliminate the need for the subsidy. But if there is no cost of capital, the overall profits of the two periods are lower with tokens than with subsidy. And this is because the recent subsidy decreases the network size in the future. So there will be more people who are exiting because now they can sell the tokens. If more people are exiting the network, then there will be fewer people staying in and providing the value. So overall value created is actually lower with that, right? And I mean, even despite that, if there is no access to capital or the cost of capital is high, it may still be better for the platform to take this lower profit, but still positive, rather than not start in the market at all. So this may be why, if you think about this innovative technologies and also technologies that rely on peer-to-peer networks, it probably was difficult for those guys to go to a bank and get a loan on favorable terms for those type of projects, or even get low cost, some favorable terms from VCs. So in environments where there is like high uncertainty about technology and people don't know whether it's going to succeed, then maybe more difficult to get capital. And in those environments, tokens may be the only way to start a platform. Okay? So, I made a number of claims. Those claims come from a model. It's a very simple model that I'm going to kind of just give you a taste. We have a simple two-period model where we have NT users arriving in each period. Users are ex-ante identical. So when they come in, they don't know whether they will like the platform or not. Only if they join the platform, they learn whether they like the platform or not. Everybody likes the platform better if there's more people otherwise on the platform. And also how much they like those other people on the platform will depend on their type. So some will be happy to stay, some will want to leave. Okay? So users can join, will choose to join the platform. They don't join, they don't get any utility, but they can join later if they're in the first period. If they joined and did not enjoy, they can leave it. They can leave the platform. And if it's just a subsidy, then they leave and they get nothing. If it's token, they leave and they can sell the token. We made the coordination problem non-trivial. So if you join a platform, nobody else joins, it's actually negative utility. You would rather not join. You needed to download an app, learn to use it, and then nobody is there. Why would you bother? But if everybody else joins, then definitely you want to go through the type of trouble. Okay? So we get this multiple equilibria, adopt or not adopt, and which one is played depends on the beliefs and the platform price, right? So this is where the subsidy comes in. If the beliefs are unfavorable and people don't expect other people to join, if the platform pays you $10, you will go through the trouble and download the app, right? But otherwise, they will not. Yeah.
What are you assuming about period 2?
In what sense?
Is there a same coordination problem in period 2?
There's also a coordination problem in period 2. So the thing is that in both periods, the platform can always set a price, such a price, so this is why the price matters and beliefs. So whatever are the beliefs, the platform can always set the price such that everybody joins. If PayPal will pay us thousands of dollars to join, everybody will join, right? It's just, this may not be something that the platform wants to do. But what we're going to assume is that if platform is successful in the first period, in the second period, the beliefs are favorable. Right? So it needs to only subsidize users in the first period, and then if it manages, then we'll have the second period success. So in the first period, we have N1 users arrive. The platform sells the tokens, and they can just set the price. They can set alternatively, they can set the number of tokens and let the market decide the price. Each user decides whether to buy a token or not. But here in the first period, we assume that you can set the price so that it's easier to manipulate. The second period, the price is definitely set by the market. Here it's either way. And then each user decides whether to buy a token or not, depending on their beliefs, whether everybody else is buying, and depending on the price. At the end of the period, everybody observes how many users joined, whether the platform was successful or not. And those who join, they learn their type, and they realize their first period benefit. So it's the utility, the usage benefit in the first period, whatever they get from the platform in the first period, plus the expected payoff in the second period, depending on their types. And this is the T that stands for tokens, right? So the expected benefit, the second period, depends whether you want to exit or to stay. And if you stay, how large you expect the network to be in the second period if you are going to stay. And if you exit, what are you getting when you are exiting? Are you selling a token, or is it so this is the token regime as compared to the subsidy regime that if you leave, you just leave, you get zero. Okay? So this is an important parameter term that is going to be different under tokens and under subsidies. So in the second period, new users arrive. Platform puts additional tau2 tokens in the second period. And then early adopters decide whether to stay. They learn the type, so they decide whether to stay or to leave. And there is some fraction, lambda t, that leaves, and then they sell the tokens. So naturally, we would expect, given that they can sell the tokens, if the price for tokens in the second period is positive, there will be more people leaving than if it was subsidy regime and they could only get zero, because now it's attractive to leave. So this lambda t is going to be larger, right? The users who have not joined yet and decide to buy a token, they can buy it from users who are selling the token and buy from the platform. In fact, platform puts the new tokens on the market, so everybody is buying it from the exchange. And exchange, the supply and the exchange comes from the exiting users and from the platform. And the price is set by the market, balancing supply and demand. This was a fun part to solve because there's a lot of moving parts, but I'm not going to show you all the details about that. And at the end of the period, everyone realizes the second period profits. Okay? So what we get, the platform kind of knowing everything else by manipulating the supply, the additional supply that they are putting on the market. They know how it's going to affect the equilibrium price, so they can indirectly affect the price, but in much more limited way than just setting the price. So what we find here is that period one price is higher under tokens than the subsidy, which is not very surprising for all the reasons that I have said. There is the higher first period revenue is higher, and that means, so this is kind of a raw lemma. But then if we interpret it, it means that sometimes without tokens you need a subsidy, but with tokens not only you don't need subsidy, but people may be willing to pay you something for the token. So the same PayPal that needed to pay $10. Maybe if they started with a token, they would be able to charge $2 per token, and people would be willing to buy it, okay? Enjoy. But the downside of the tokens is that the second period's revenue is lower, and it's lower for multiple reasons. Number one is in the second period, the platform sells fewer tokens because now there are all those tokens from early users. That the reason why they could charge higher price in the first period is because those early users some of them are going to resell, right? So just numbers are lower. But the second factor is as living becomes more attractive, the network is smaller, and that means that the price for tokens in the second period is lower under tokens than the price for access if there was subsidy. So exactly the same model in the second period, there would be more people staying in the second period. Joining the platform would be more attractive. There would be the only game in town, this platform selling the access. They can sell at the higher price and to more people. Okay, so for both of those reasons, the second period's revenue is lower. Yeah.
That's the question. So are you assuming all people that are leaving the platform will sell the tokens?
So yes, I'm assuming that if they are leaving the platform, they will sell their tokens.
There is management on like what portion of the people that selling their tokens impact the price, or just assuming that all will sell.
So I'm assuming that if they already learned that they don't want to stay on the platform, so they can either hold the token, get zero for the, like not get anything for their token and not get any utility from the platform, or they can sell their token at some positive price, so they will sell the token. Okay, so this is why I'm assuming that. It is an artifact of the fact that the world ends in the second period in this model, right? If you think that there would be a longer period and maybe you don't want to use the platform, but you think the price is going to go up in the third period, the fourth period, you may want to hold on to that, to the token. The thing is that as long as there is any positive fraction of those who are exiting that are selling their tokens, the effect is going to be there, even if it's not all of them. But as long as the moment there are some users who are selling their tokens, there will be this effect that there will be fewer tokens sold by the platform in the second period, right? Because for every token everyone who sells. So if you can sell it at the positive price, there will be some people who are incentivized to exit the platform, even though they would not want to exit it if they would not get anything for it. So, well, if there is zero outside, I may have some epsilon from consuming the platform, I will stick around. But if I can get $2 for living, I'm out of here. Okay? That is going to decrease the size of the network in the second period, and this is going to decrease the price anyway. So both of those effects will be there, even with just small number of users selling.
So if I understand your last correctly, having the tokens could also potentially cause people to run for the exit. So it could have an effect that the decrease in price or the decrease in the perceived utility could cause people to say, actually, I want to leave because now I can make a profit and I want to make all of the profit.
Yes, okay. Yeah. So more people are leaving if leaving is associated with some positive payoff from selling the token. Now the thing is, not everybody is going to leave, because if now everybody wants to leave, the equilibrium price will be too low, so that makes fewer people want to leave, and this is how we are getting equilibrium price. So there's some equilibrium price, some people will stay, some people will leave. So we have the first period's revenue goes up, second period's revenue goes down. So, are the tokens worth it or not, right? How does it balance out? And it wasn't obvious right from the beginning, but we did, a lot of math behind and analysis, and we firmly went out on the side that the total profits of the platform are lower when it issues tokens rather than when it takes the subsidy. There's no discounting between the two periods. And the intuitive reason for it is because tokens decrease social welfare. More people leave and more people create the network. More people leave, so fewer people create the network, and therefore the value of the network effect is lower. Okay? So subsidy is more attractive if there's access to capital and it is not too costly, right? Of course, if the access to capital is too costly, then the entry doesn't happen in the first place. So lower profit is better than zero profits. Okay? So to kind of to sum up, this first part is that if we think about utility token as a platform access or token that is allowing to use the platform, and platform can commit to accepting the tokens in the future, right? Because going back to this point about the bad effects of tokens in the second period, it's exactly the reason why the platform, if they would call the token invalid in the second period, right? And sell more of the access at the higher price. But if they do that, or people in the first period expect that this is going to happen, then all this positive benefit in the first period is going to be lost. Okay, it's important. And users who exit the platform can resell the token. So that will allow to increase the price and profit in the first period of the entry, and may eliminate the need for subsidizing. and lowers the profit in the future. So platforms because platforms have fewer tokens and at the lower price. Something that I didn't emphasize until now, that means that tokens redistribute welfare from platform to the users. So those users who are selling their tokens in the second period, they are left with more surplus, consumer surplus, than if we were in the case of subsidy. Okay? And also the users who are joining the second period, they are getting lower price. They're getting lower benefit, but even lower price. Okay? And but overall welfare and platform profits are lower under tokens and under subsidy. Right? So we need to think about which effects may be more important. Right? And this is because resale encourages user exit to a larger extent, and overall network smaller is and the overall network is smaller in the future. Okay? So tokens are attractive when subsidy is not possible or too costly, because also subsidy may not be possible for other technical reasons, not just capital costs. There any? I mean, this is a good time for additional questions on this. Yes.
I have a question, and feel free to say if you want to answer it now. But you're thinking about this as kind of the network users are the providers of the service of the network, and they're also the ones who consume it. Right? Just by having the token, you get value, and the more people who have access, the more value.
Yes.
In principle, and in the examples you gave, there are people who pay for service. I pay to store my files, and people who store the files. They may not be the same. So I'm curious if there's anything lost by not thinking about those two sides of the network participants, as opposed to just massing it.
Yes, so we are explicitly thinking about about one-sided platform for modeling purposes, and the alternative is the kind of okay. So I will give a short answer. Is that and the longer answer over lunch. The short answer is that the effect also travels to two-sided markets under some conditions about the access, the need for utility tokens to access the platform. And we can think about it as I need to buy the tokens. And then I need to be able to sell the tokens as well. And if I can not able to sell the tokens, it will also create the frictions. And if I'm selling the tokens, I'm selling the tokens to people who are buying the tokens. With Filecoin, in fact, it turns out that most people are on both sides of the transaction, and therefore they are not completely separated, two-sided. So if you are at the same time you may be providing service and you may be using service, then it falls more into the one-sided market analysis than completely separating the two sides. Yeah. Yep.
So what's the connection to like a token? Like if Uber just gives a bunch of free rides to people, can I think about that as a token? What's the difference between that and the utility token you have in mind that's linked to the smart contract?
So free rides are different than the token, because free rides is money that Uber needs to pay to the drivers. So they need to have a capital to do that. So free rides is subsidy rather than the token.
So what's confusing is like the unit that we're paying in. So Filecoin has to pay with some cryptocurrency because there's no like checkout counter paper cash. And so it sort of has to have some kind of token. But it's also playing a role in this sort of network.
Well,
so and the same with,
yeah.
I mean, Uber could run with tokens on some blockchain, but the driver still needs to put gas in his car for money. So it's the same. So I'm trying to sort of connect up this like, what's the right sort of comparison? This is a token versus this is a subsidy if I live just on a blockchain.
So for example, the difference is that Filecoin could run on a stable coin, but they decide not to run on the stable coin. They decide to run on the token, the price of which is going to be set up by the market. And the difference is also that tokens can be given out before they need to be cashed out, and they are given out without the need of any upfront capital. So I can give you a token that you can later you can use the platform with this for this token.
But why doesn't that work at Uber? Like I give out these tokens and the driver gets the token in the same way that the supplier of file point gets the token. But what would it look like at Uber then?
Well, so in Uber, you can think about the free ride as a token, but the driver needs to get cash. Here, the company, when they give out token, they don't need to give you cash. So if they are giving you a token, they are not giving you $10. They just created the token out of thin air. So if Uber would create a token and then the driver would take the token rather than the cash, then it would be okay. But the driver is getting cash, and this is why Uber is kind of needs to run against the capital, the cost of capital.
Yeah, but I guess what I'm missing is like, what's the difference between Uber and file?
In the sense of financing
I get they
access.
made a different choice, but like,
Yeah.
I could run Uber like file,
Yeah.
couldn't
Yes. Yes. So that's the thing, is that you can have the platform could be the same platform that decides whether to use the token or to use cash. When you are issuing a token, you don't need to. You're just issuing token out of thin air, but you need to commit to accept it in the future. If you're getting free rides from Uber, then you have some expiry date. They are not for the future, right? But you could imagine that Uber would be using a token and say, we're committing to you're buying tokens, you're prepaying for your future rights, and you can pay for it now, but we are committing to honor it in the future. The thing is that they are not doing it. They went for this for the regular subsidy, and it may make more sense. Where first of all, they didn't have exactly this technology available when they were first entering. But if you are going to go for the subsidy, the overall profits will be higher because you're not allowing. So another difference is when you are getting your free rides from Uber, you cannot sell those rights to Haeringer. You cannot sell those rights because if you would get some free rides from Uber, then you got 3 rides, you tried one, you didn't like it, and you say, Ariel, I'm going to sell you those 3 rides for $5. You can't do it. So this is the difference. There's no tradability of the subsidy.
Hanna, this is Param here. A quick question on this. So there is, so in one case you are saying that the platform provides subsidy as a price, as some hard cash almost, right? So which the value of which is not changing in your model. In the other case, you are providing something of value, which initially to the platform seems to, like they can hand out as many tokens as they want at a lower price, but the value of that would increase over time if more people join and you can trade off from there. So in effect, like even we think of like you're not giving subsidy, but you are providing not hard cash, but something of value to the platform. If we were to calculate the expected value of those tokens, right, based on based on the beliefs and so on, what they would be in the second period, would the subsidy and the value that you provide through tokens, are they very similar or there is a big difference between the two?
So the subsidy, I don't know where is the microphone. So the subsidy that you would need to provide to convince people to join if the beliefs are unfavorable needs to be larger than if you are providing them with this exit option. So really the importance is the resellability, the fact that you can resell the tokens if you don't like the platform.
And is this because the value of the token actually increases? So even though you are giving a smaller value product, it increases in the second period.
So it doesn't have to increase. Okay. So in this model, in fact, we get parameter values where the token price decreases, and everybody knows that the token price is going to decrease, but they still have some expected utility of using the token in the first period, and then some positive value from selling this token if they don't like it. Okay. So either this, so it's like an insurance policy.
Okay, thank you.
So something that I want to briefly finish with is a simple example about the governance tokens and value creation and distribution. Okay, so the DAOs. So like other blockchain technologies, DAOs promise to prevent value capture by powerful intermediaries. So this was the second problem that comes from network effects, by decentralization, disintermediation, distribution of value, otherwise captured by centralized intermediaries. And all this typically in a permissionless environment. It's important because the moment you have permissioned environment, you have someone with power. And the idea is to eliminate any power. So we show, bigger model, we show it more exactly here in an example, that this disintermediation happens only under very narrow conditions. And this is like when you look at the rhetorics without the model, this looks plausible, but then doesn't fall for more general environments. In more general environments, we have forces towards centralization, and they make the platform intermediaries. You are not going to get all those promises delivered on in the long run, right? Unless we have some additional safeguards that still need to be developed, okay, to sustain this intermediaries. Okay? So think about the very simple model, right? We have some n potential users. They are distributed evenly between 0 and 1, and they have some k utility from using the platform. Right? There are no strong network effects. So the reason why this is very nice is because it gives us this nice demand curve, and I'm sure you have all seen it if you've ever taken Econ 101. Monopoly is going to charge price 1/2. There's no cost of providing the service, and it's going to make some people join the platform, and it's going to create that way clause that some people are going to be priced out. Okay, so this is a very typical result. Now enter the DAO, and let's say that we have this intermediary where there's no central authority making pricing decision, and all potential agents get a governance token, and this governance token will allow them to vote on the price peak. Okay. And they are considered to make it efficient. They're considered in certain order, so it's from the highest to lowest and so on. And the one that's in simple majority voting, right? So this is what DAOs are promising. Okay. Now potential users decide whether to pay the price set by the DAOs. First, the DAO sets the price, and then users decide whether to pay the price that they decided or not. Okay. And collected profits, if the price is positive, are distributed to token holders as the dividend. Okay, so this is the redistribution one. Okay, so DAO could set the price equal to 0, and if it does, it maximizes the social welfare. There's no net weight loss. Everybody is happy. There's no cost of provided service, so the price could be 0. Okay, so DAO could set the price to 0, but will DAO set the price to 0? Right? So some potential users with low utility of using the platform will prefer to set high price and collect high dividend rather than setting low price and participating in the platform. Okay, so non-users will prefer the monopoly price. Users would prefer price 0. Okay, so we kind of do a quick calculation, and with this simple model, 1/4 of the users will prefer high price, and 3/4 will prefer low price and participating in the so with majority voting, DAO sets the price to 0. Yeah, right, that works. This is great, but it works when everybody has one token. Okay? Now the thing is that tokens are generally tradable, and if we think about, for example, governance token being auctioned off, or maybe everybody gets an airdrop of a token, and then there would be they can sell the token. It turns out that this result may not necessarily hold. Okay, so every potential user decides upfront whether to buy a token and how many tokens to buy, and they can buy multiple tokens. Okay, and if they buy more tokens, they are getting more of the dividend. So as the price increases, they are hurting because they need to pay the high price. But if the price increases, they are getting more and more dividend. And the more tokens you have, the more important is the dividend, and the less important is the price that you pay. Okay? So if the access price is positive, then you want to get as many tokens as possible because this is at whatever price. I mean, if the price is such that you want to get one, you will want to get multiple of them because they provide positive dividends. Okay. In fact, and this is kind of the most important result here, everything else follows, is that if a user finds it profitable to buy one token, then he will find it profitable to buy all of them. The more tokens you have, the higher is the value of each next token. And this is different than in most of the economic goods, because for most economic goods, the more you have, the lower is the additional utility of the next one. Okay? But this is the case if you own less than half of the tokens, then you are getting some dividend. So you always want to get, if you want to get one, you want to get more. If you own more than half of the tokens, then you can set the price. And then you get not only more tokens, but each token gives you higher dividend. And the more tokens you have, the higher price you are going to set. So the more tokens you have above 1/2, not only you get more dividend, but also you are setting increasing price, so you're getting each dividend pays more. Okay? So with that, we're going to get one user wanting to pay all the tokens. The question is, who will be the highest bidder to buy all the tokens? So non-user, if the non-user is controlling majority of tokens, it will set monopoly price. Is it going to be higher or lower than the user, right? So we find that users, because they also get this utility of using the token and using the platform, they will actually bid higher. They have higher utility of owning all the tokens because they get utility from the dividend plus the utility of the usage. Okay. So then if allowed user of the highest type is going to buy all the tokens. This was the user that had the highest incentive to set the price to 0, right? When they only had one token, right? But now they will set the price that is slightly lower than monopoly price, but just slightly lower than monopoly price. Okay. So basically, this is like a quick example to show that there are really incentives to re-centralize. And the moment you have more tokens, you want to set higher price, no matter what you were saying when you had one token. So to kind of sum up, when agents are differentiated, and this is important because without differentiation, we are getting this very nice result that everybody is happy, and tokens are tradable. There will be always fewer players who will have higher willingness to pay for the tokens, and because of this concentration tendency that the value of tokens increases with holdings, we are going to have few users having higher willingness to pay for all the tokens, right? And with many tokens, the trade-offs change, so you want to set higher price. So that means there are some, am I out of time? I'm out of time. So there are some ways of preventing it so far, but they are creating additional problems. So far, they are not, these problems are not convincingly prevented, and we need more research on how to create a different, a better setup for DAOs to really prevent the centralization and concentration. Okay, this is my last slide, and I'm just going to basically summarize that blockchain technologies offer new solutions to old problems, but they may come at the price or not work as expected. Thank you very much.
I think we're out of time. I'm sure Hannah's happy to stay for a few minutes
I'm happy to
if anyone
stay.
has additional questions, but otherwise we'll adjourn. Thanks, everyone.